Welcome to Spring LIB.
Hi, here for the given question we are given that Tn is equal to 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 upon n minus log e base n. Now here we need to prove that this given sequence has a limit. So here in order to start the proof we will start with Tn is greater than 0. So here first of all we need to prove that. So here as we know that this is a harmonic series and here the series will be 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 upon n. If we consider this part only, then here for this part of the series we know that this is a decreasing series, and if we take this then here an will be 1 upon n. So if we substitute limit n tends to infinity for an, the value will be here limit n tends to infinity for 1 upon n. So here this value of an will be greater than 0, which implies here our Tn, which is an minus log e base n. So here this value will also be greater than 0. So Tn is greater than 0, and further here we can say that here Tn is greater than Tn plus 1. So here in our case this is an increasing sequence, and further here in our case now we can apply here the monotone bounded theorem. So here we know that here in our case now as we have shown this two condition for all n, and here both the sequence are here increasing and they are bounded above. So here we can say that by monotone convergence theorem here Tn has a limit. So further here in our case now we can find the value of the Tn if we take integral test. So here in our case we have integration over 1 to infinity. We will take 1 upon n minus log e base n dn. So by integrating this we have integration of 1 upon n will be log e base n, and here integration of this log n, here we will use integration by parts method. So here in our case for integration of log e base n, this can be written as here the value of this integration will be log e base n minus here next term will be integration of v du. So here this will be our u. So here in our case we have n into n log base n, and here we have value as 1. So this can be written as n into log e base n minus n. So n into log e base n minus 1. So this is the value of the integration. So substituting over here we have n into log e base n minus 1, and here the whole value has a limit from 1 to infinity. So here by substituting the value of the limit and solving this, here we can say that we have limit equals to 0. So here we can say that the given sequence 1 upon 1 plus 1 upon 2 plus 1 upon 3 up to 1 upon n minus log e base n has a limit, and the value of limit is equal to 0. So this is our required solution. I hope you understood very well. Thank you.